7.2 is simplifying radicals. So in this section, we're going to be simplifying radicals without using you're going to be allowed to use your calculator, but I don't want a decimal answer. I want you to simplify these to be exact answers. And it's a pretty long section. We do a couple adding, multiplying, dividing, so I split this up into a couple videos again. One thing you need to remember is that all the exponent properties are the same from chapter 6. Okay? You will be dealing with a lot more fractions, so just remember how to deal with fractions. X times x, you're still just adding those exponents together, so 1/2 plus 5/2 should simplify to 3. So it should be x cubed. Everything gets brought to the 1/2. Now one thing you have to start thinking about is when you see a fraction, think about what radical that would be, what root it would be. 1/2 is a square root, so we are square rooting that 9, so your answer should be 3. And you're going to multiply those exponents, x squared. Okay? So all those exponent properties are the same. They're going to be the same work that we did before. Okay, just remember the parts of a radical. We have our index, which is going to be important, and the n that's underneath the root, that is called our radicand. Okay? You cannot have a negative index. Okay, so we're not working with this. We're kind of the same concept as when we had negative exponents. We brought it to the bottom or the top, moving it to make it positive. We're going to be doing that same kind of skill here when we have a negative index. Okay, now, writing radicals as powers. Okay? When you have the nth root of x, that can be written as x to the 1/n power. All right, just think of the square root that we just had. Okay, square root of x. The index is 2, and I said the 1/2 power is the square root. Okay, so that's what you'd be looking for. Now you should be able to go in both directions, taking a radical into a power, but also a power m to the 1/8, and that could be written as the 8th root of m. Okay, so if you notice, the index is the denominator of the exponent. So it was 1/2, that's a square root. When it was 1/8, 8, that denominator became the index. Okay, and that's going to be important when you get things such as a to the 4/7 power. Okay, if I ask you to write this as a radical, the denominator is 7. Okay, so it's going to be the 7th root a to the 4th. Okay, and another way you could write this, that 4th power could also be outside. You could have the 7th root of a and have the 4 be outside as such. Okay, so either one of those would be acceptable. Okay. Make sure you're paying attention if you get something such as the cube root of a, b, let's say a, b, c to the 9th. If I ask you to write this as a power, I'd like to see each piece of this, a, b, c, having their own exponent. I'd like you to write it as a to the 1/3, b to the 1/3, and then that c, it'd be 9/3, which simplifies to a third, or sorry, not to a third, to the 3rd power. Okay, this is how I'd like you to write your answer then. So just make sure you're thinking about every piece and the difference between the cube root a, b, c to the 9th, and the difference between that and the cube root of a, b, c to the 9th power. Okay, well now this a, b, c is in parentheses to the 9th power. If we were doing this, remember that 9, everything is going to be brought to the 9th power, so everything is going to simplify to 9/3, 9/3, 9/3 power. A cubed, b cubed, c cubed would be writing it as a power then. Okay, and that's how I'd like you right now. Write it so each piece gets its own exponent. Now, if you're simplifying with no radicals, okay, oh, sorry, skipped it. Simplifying with no radicals, we're going to have things such as the cube root of x to the 9th. Now we just did a little bit of this. If I was rewriting this, okay, it would be x to the 9 over 3rd power, which simplifies to x cubed. Okay? So really what you're doing is just dividing. Taking the exponent, divide it by the index and see what happens. Okay? The 5th root of a to the 4th. Oh, I'm sorry, I want to do a to the 10th, b to the 15th. This would simplify to a squared, b cubed. The 10 divided by 5 would be 10 over 5 would be 2. 15 over 5, 15 divided by 5 is 3. Okay, now both these examples worked out nice. If it doesn't work out nice, say if 5 doesn't go into one of those two exponents evenly, let's see how that would look. Let's do the 4th root of a to the 10th, b to the 12th, and c to the 8th. Well, 4 going into 10 doesn't go in evenly. You have a remainder of 2 there. Okay? So yes, 4 goes into 10 2 times, so we are not to have a squared, but since there's a remainder of 2, I'm going to keep a squared on the inside as well. Okay? The remainders are going to stay inside. All the ones that go into it nicely go on the outside. 4 into 12 is going to be b cubed, and 4 into 8 is going to be c squared. And there's your answer. Look at each piece separately. You have your a, you have your b, you have your c. Now if I was going to take, if we have a coefficient in front of these, you deal with that the same way you would deal as we have been with either factor trees. I am not expecting to be able to do factor trees with the cube roots, okay? Maybe even a 4th root, but you should be able to simplify those as nice as possible. Let's do one with a square root, 64, x to the 11th, y to the 14th, z to the 21st. Okay, now remember, square root, the index is 2. Well, the square root of 64 is going to be 8. So that one works out nice. 2 goes into 11 5 times with 1 left over. So we're going to have x to the 5th. And we're going to leave 1x inside because there was a remainder of 1. If you want to put the 1 there, you're more than welcome to, but you don't need it. 2 goes into 14 7 times. Nothing left over. 2 goes into 21 10 times with 1z left over. And there would be your answer. Okay? Let's do another one here. Let's do the cube root of, let's say, 10x to the 10th, y to the 5th. Let's just stop there. Now the cube root of 10, it doesn't simplify. You can't do a factor tree for it, so we're just going to leave it cube root of 10. Don't force anything to happen. If you can't do something, you can't do it. So we're going to have the cube root of 10. 3 goes into 10, that exponent there, 3 times. So we have x cubed, and there's 1 left over. 3 goes into 5 1 time. So we're going to have 1y on the outside, but a remainder of 2, y squared. And there's our answer for that one. Okay, so you're going to have to do some step by step. It does take a little bit of time. Okay, let's do one where you do have to have a factor tree. We can do a factor tree. Let's do the cube root of 250, x to the 9th, y to the 14th. Okay. Well, that 125, you do that factor tree just like you normally would. Okay, be 125 and 2 times. You're just using the cube roots instead of the square roots like we did in chapter 5. Okay, the 125 goes to 5. So we're going to start off with 5 cube root of 2. Now you do the exponents like we have all these other ones. 3 goes into 9 3 times. And there's nothing left over, so we just have x cubed on the outside. Nice things go on the outside, the remainders go on the inside. 3 into 14. 3 goes into 14 4 times, so we're going to have y to the 4th, y squared because there's a remainder of 2. Okay, so in this case we had to do a factor tree. And there you go with that. Okay, so here's some examples. You should go get some practice and try and figure out what's going on with these. See when you're going to have to do factor trees and how you rewrite your answers once you are doing it piece by piece, and make sure you write it nice and neat in one term. This is one final answer. It's not all different pieces. We might do it piece by piece, but it is one final answer.